Howdy! Welcome to Aspire Mountain Academy. I'm Professor Curtis, your instructor for this course in introductory statistics. In less than 10 minutes, this video introduces the LeastSquares property and describes the old school iterative process used to create a linear regression model. Let's get started. So the LeastSquares property says that if the sum of the squares of the residuals is the smallest sum possible, then you have your line of best fit. So it's the residuals that we use. We calculate that, and that's what we use to determine the line of best fit. So we basically put the line there on the graph, and we take the residuals, and then we're going to move the line a little bit, recalculate the residuals. We're looking for the sum of the squares of the residuals to be the smallest sum possible. So this is really at the heart of how we produce a regression line, the old school way. This is more of a graphical analysis technique. So calculating the slope and the y-intercept that we saw in previous mini lectures, that's an algebraic solution. This gets you to the same spot, but it's more of a graphical solution. We start by placing the line of best fit where it seems to be best there on the scatter plot. We calculate the residuals with that line, and then we add the residuals together. So we're going to find the sum of the squares of the residuals. So we square each of the residual values, we add those squares together, that's the sum of the squares. Then we move the line just a little bit. Calculate new residuals. Okay, we're going to get a new sum of the squares. We compare that with the old sum, and that comparison tells us which way to move the line. So we move the line according to the comparison. So if the new sum of the squares is less than the old sum, then we're going to keep moving the line in that direction. If, however, the new sum of the squares is more than the old sum of the squares, we're moving in the wrong direction. We got to move the line back the other way. And we just keep tweaking the line like this, recalculating some of the squares of the residuals until we find the placement of the line that gives us the smallest sum of the squares. And that's basically what it is. Computers are really good at this. People, not so much. Computers can give this to you instantaneously. People will take, oh gosh, minutes, hours, sometimes days. I mean, it just depends on your data set. But you can see that if you've got a large number of data points, trying to do this iterative process by hand is going to be a real nightmare, because you've got to calculate all these new residuals and add up the sums of the squares. So yeah, it can be pretty painstaking work if you're doing this the old school way. That's why computers are so great. Computers will just do this instantaneously. They give you an answer. You don't have to wait for it. That's a beautiful thing. This is why the regression line is also called the line of best fit and the least squares line. So now you know where these other names for the regression line come from. It comes from this least squares property, and the method that's based on the least squares property that produces the regression line. And that brings us to the end of this mini lecture. I hope you found it helpful. You can find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching. I'll see you in the next video.